Hi, everyone. I want to introduce our group project. We try to execute continuous delivery of our microservice. This diagram shows the overall flow of our project. First, we chose a Kaggle dataset about global temperature, and we scraped this dataset by using Kaggle API, and we put it into RDS database like this. And then we did some EDA about the dataset and made some functions to answer our questions about the data. And then we put those functions under the FAST API to generate our microservice. And we used a Docker image to containerize the application and send it to ECR. And then it will trigger code build and app runner, which hosts our application. And lastly, we built a user interface for users to more easily access information about the data by using Streamlit.
Thanks, Song. Our dataset starts from 1750 for the average land temperatures and 1850 for max and mean land temperatures and global ocean temperatures, respectively. In trying to understand our dataset, we decided to do some EDA, mainly trying to understand a few questions. For example, given a country, what's the trend of the average temperature? Or given a year and given a country, what's the mean and max temperatures? Or given a city in a country, what's their maximum and minimum temperatures? Our app mainly focuses on doing EDA. So if a user kind of, for example, gives an input, it returns output from the app. A number of other questions we looked at were, for example, the average temperatures over the last century and the last decade. We also looked at the differences in the temperatures based on season. For example, have temperatures changed during winter for the last 100 years, or have temperatures changed during summer for the last 100 years?
I'm going to talk to you about test logic. The purpose of test logic is to be able to test your functions and make sure that they are behaving the way that they should. So for example, I know that in EDA's get EDA1 is get future temp. I know that, for example, if the output's going to be a JSON payload, and I know I can read that into a data frame, and I know that I can assert that the earliest year is 1850 and that the latest year is 2013. So if it doesn't meet those criteria, it means that the function failed somehow. And that's the purpose, to be able to troubleshoot your own functions. One of the great things about our functions is that we can wrap them in executable scripts, and we can turn them into command line tools. So one of the ways that we do that, for example, is with Python Fire, and we can import all of these functions that are from our EDA Fire Q1 file. And once you wrap them in there, if you write help in the doc, it'll show you the documentation of your own functions and with their respective doc strings as well. And the great part is that instead of having to go through a terminal or something like that, you can actually just run them from the command line, and instead of the Python terminal. And when I run it here, for example, with the function and its arguments, you get the output right here in the terminal. Now I will be talking to you about continuous integration. Continuous integration is a process of constantly revising and testing your code on each and every push. And it's what allows you to sanity check your code. And for example, here we make a special note that we also have elements of deployment and continuous delivery, because on every push there's an deployment. And we also made it so that the presence of the credentials is able to aid that deployment. And this is what a successful build looks like. It's always supposed to give you that green check mark. And you establish this in GitHub workflows, GitHub actions. Now we will talk about continuous deployment. So continuous integration is sanity checking your code and making sure that it's stable and ready for production. So where does it get deployed? Where does your final microservice or web app go? Well, a good option is cloud computing, and we chose AWS services, and we chose Elastic Container Registry. So once the Docker image is built, it's sent directly to be housed. This image is housed in ECR, And then also in addition, in an hourly to daily basis, depending on how you calibrate it, code build is acting as a continuous integration, and it's also building out that code and running it in its own environment. But that image specifically goes straight into AWS App Runner, and it gets deployed there, as you can see by the logs. And then if I click this link, that link is available for anybody that I could send it to. So for example, and here are APIs. So I can try them out right now. Everything's there. It's already been deployed. I'm going to say Armenia 2010. And here's the result. That's continuous deployment.
To build our APIs, we used Fast API. For each of the API functions, we use the get method, which takes inputs in the form of query string parameters. Our APIs wrap our business logic and return JSON objects. To construct plots in the front end, we return JSONified pandas data frames and use Streamlit support for RDS and Matplotlib to construct the plots in the Streamlit app. For our user-facing front end or web page, we use Streamlit. We call the APIs that are hosted on App Runner and get the JSON encoded data. We decode the JSON, convert them into pandas data frames, and use these data frames to build plots using support that Streamlit has for Altair and Matplotlib. We also use other Streamlit capabilities like containers and tabs to divide up the contents of the web page. This is our rendered web page on Streamlit. Here on the home page, we have the global average land temperatures for the last century and the last decade. Here we can see an obvious rise in the trends for these graphs. Here in the second tab, we have our interactive graphs. Here the users can query the trends they want for a particular year. There's also minimum and maximum temperatures for a particular year and country. And which cities in a particular country have the highest and lowest temperatures for a year. In the next tab here under predictions, the user can select a country they want to predict the temperatures for until 2050. We have one last tab that allows us to analyze the way seasons have been changing for the world's highest and lowest polluters. I will move to that as soon as this finishes rendering. Yeah, this is the temperature forecast for Andorra. Here we have the trends for seasons for the world's highest and lowest polluters. That's all we have for you today. Thank you so much for watching.